Bismillahirrahmanirrahim. Yes, hello everyone. So this is Dr. Bassam Alhamad. So we'll be taking lecture 13 for the course CHENG324 Process Modeling and Simulation. Okay, great. So what we are going to be taking, we are going to be taking together. Some examples, and we're going to take about 8-9 examples maybe of how to undergo partial decomposition. So we are saying that if we transfer the time domain to the S domain, okay, so what you're trying to say that if we have something in the time domain and we do some kind of Laplace, and usually the thing which is in time domain is our model equations, okay, that dh by dt, the dca by dt, the dt by dt. So what you're trying to do, we take Laplace, and taking it into Laplace, we'll have our S domain, in which we call transfer functions, and how to undergo Laplace. We already have taken some examples of how to do Laplace. For example, if it is a constant, it becomes a constant over S. If it is a ramp, for example, a t, in the sense that's a t, so it becomes a over s square. Okay, if it's a over t, it's a over s square. Or if it is something like exponential term, which is 1 over s plus a. If you want to take it back, it becomes e to the power minus at. So all of these kind of things that we are trying to deal with here, okay? So we want to take it from the time domain to the S domain, which we call transfer function. There is a route in which, before we go to the Laplace, there is a route in which we need to do some kind of linearization, and then putting it into deviation format. And after putting it in deviation format, we do this Laplace thing. So what we have not taken so far, is this part here, which we are going to take next lecture. But we are just training ourselves. Of how to use or to do the Laplace domain thing. So what we are trying to say here, that if we take it from time domain to the S domain, and we get an answer, that looks like that: 5s minus 3, for example, over s square minus 3s minus 4. So if we get an answer which looks like that, the thing is that how to take that into time domain, okay, to get the solution. So we want how to take it back to y of t, which is the solution. I don't know what's going on with that thing. Okay, so that we can get the solution. So this is what we are trying to find out here. We are trying to find out the solution. That is our goal in this place. So we're going to take some examples. Okay, so the first example we're going to take, the one that I just stated here. So example number 1. Okay, so in this example, as we are saying, we are going to take the same example. So if I would say that I have my example here, which is y of s. So I'm getting now the S domain, for example, and my S domain is equal to 5s minus 3. Okay, 5s minus 3, and s is just like it's like an x function. It's just a variable, right? But now we know that this variable is something like an S domain. Okay, so if we have something like that, so this is my problem. So how I can change that into y of t? So the problem is like, simply says that find y of t. Okay, y in the time domain. I said, okay, I want to change this into the time domain, but oh my god, Laplace. I don't have the Laplace of those stuff. I don't know it. So this is what you're going to do. I mean, we don't know it, so what we need to do, we need to do the partial decomposition, okay? So the thing that we need to do here is partial decomposition. And they also call this like partial fractionating or something like that, okay? Fractionation. So this is what we're trying to do here. So what do we have? We have 5s minus 3, okay? So 5s minus 3 over s squared minus 3s minus 4. So what we are going to say, like this is the denominator here. The denominator is to the power 2, okay? The denominator here is to the power 2. So we are going to have something to the power 1 at the top. But hold on. We will not do that except when we see that if you can factorize the function which is at the bottom here. And if you look at it, yes, we can factorize that. We can factorize this function to be s minus 4 into s plus 1. And factorizing that function, now I have my denominator is to the power 1. And since it is to the power 1, so the fractionating numerator will be to the power 0, okay? Which means one order less. It's one order less. So this will be a over s minus 4 plus b over s minus s plus 1. So this is what we are trying to do here. We are trying to decompose this function into these two fractions, okay? Into these two fractions. And in doing this, if you look at it, can we transfer this from the to the time domain? Yes, definitely. This is a into e to the power 4t plus, and that is b e to the power minus t. So as you can see here, we can get our answer directly. However, what we need to do is to compute the value of a and to compute the value of a and the value of b. So if I would consider that in the exam, if you're stuck with time, just try to find your final look of the answer, because to find a and b, it will have some count of marks, but it will be very low in comparison that to find this final shape or the final answer. So do consider that. So what we're going to try to find, we're going to find the value of a, and we want to find the value of b. So this is what you are trying to find, okay? And here actually it looks like even that this e to the power 4t that goes to infinity if t goes to infinity. So when I'm looking at that process, I know that this looks like an unstable process. I know it's too early to mention stable or not stable, but I just click into your mind that, okay, so from the S domain that comes from the time domain, from this S domain that I have here, I can know that if the system is stable or not. Beautiful. Just by looking at this denominator terms. Okay, so let's go back. So I had 5s minus 3 over s squared minus 3s minus 4. I factorized the denominator. My denominator is to the power 1 in that bracket. So if it's to the power 1, so my numerator in my fractionation process will be to the power 0. So that is nothing. So s to the power 0. And it will be a over s minus 4 plus b over s plus 1. And a over s minus 4, 1 over s minus 4, if we transfer 1 over s minus 4 to the S domain, to the time domain, it will be e to the power 4t. If I just recall that for you, so it's like Laplace of 1 over s plus a, if you can remember that, Laplace inverse of 1 over s plus a is equal to e to the power minus at. And since a here is minus 4, this will be minus 4, so it will be e to the power 4t. And in the other one, the other term we have, it is equal to 1, my a. So 1 over s plus a, b will go outside. So 1 over s plus 1, if a is equal to 1, this will be e to the power minus 1t, and that is e to the power minus 1t. Beautiful. So what we need to do here is to do what? Is to calculate the values of A and B. Beautiful. So now my problem is a little bit simpler and I'm going to work on it. So what we are going to do here, so writing my function again, just to write my function again. So what do I have? I have 5s minus 3 over s minus 4 into s plus 1, and this is equal to a over s minus 4 plus b over s minus 1. Okay, so that was our function here. So what we are trying to do here, we will multiply both sides by the denominator, and if I multiply this by the denominator, it will cancel out the denominator here. So simply what I'm trying to say here, I'm saying that 5s minus 3 over s minus 4 into s plus 1, I multiply this by s minus 4 into s plus 1, and I do the same for the right hand side. So this is multiplied by s minus 4 into s plus 1, which means I'm going to cancel out those terms. Plus I'm going to have plus b over s minus 1, and this is also multiplied by s plus 4 into s, sorry, I think I said s plus 4, that's s minus 4 into s plus 1. And of course, why I'm confusing myself? Okay, it was plus 1 here, that was the confusion. Okay, so that is s plus 1 and that's s plus 1. So s plus 1 will cancel out here, and of course this denominator will cancel out the denominator, and then you're going to get used to it. You will not write this step, you will just directly write this step here. It will be very obvious just to write it directly. Okay, so it will be very obvious to write it directly. So it's into s plus 1 plus b into s minus 4. Now if you just look at this, there are two ways how to solve it. Okay, there are two ways. So I'm going to write here two ways of how to solve this problem. There are two ways. Actually, there's more. Okay, let me say there's more. But at least I will present two ways here. You're going to use either one of them, and you can use other if you'd like. So there are many other ways. So talking about the first way that I'm going to mention here. So I have 5s minus 3, which is equal to as plus a plus bs minus 4b. Okay, so I just multiplied that into the brackets, and what do I have here? I have my terms 5s is equal to as plus bs. Okay, so it's 5 is equal to a plus b, so that is my first equation. 5 is equal to as plus b. My second equation is minus 3 is equal to a minus 4b. So minus 3 is equal to a minus 4b. So what I have done, I have kept the s together and I have kept the numbers together. So that was how to solve this, and these like are two equations with two unknowns. Okay, so this is two equations with two unknowns, and then you're going to solve your problem. So that's one method of doing it. Okay, so that's one method of doing it. So let's see what is the second method that I can use here. The second method is as 5s minus 3. I'm going to write the equation into a into s plus 1 plus b into s minus 4. So simply what I'm going to say is I'm going to cancel out one of those terms. So how to cancel out? If s is equal to minus 1, this will be minus 1 plus 1, 0. So I'm going to cancel out that term here. So if s is equal to minus 1, what will be my problem? It will be like that. It will be 5s minus 3 is equal to, this term is going to be 0, plus here if I substituted, as I said, minus 1. So this will be minus 5b, right? Minus 5b. And of course I said minus 1, so this 5s minus 3, it will be 5 into minus 1. Okay, so that will be 5 into minus 1, which is minus 5, minus 3. And that will be minus 8 is equal to minus 5b. And then I'm going to say b is equal to 8 over 5. b is equal to 8 over 5. And you can see how simple that was to solve. And similarly, if I'm going to say s is equal to s is equal to 4. And why did I say 4? Because I know that here it says s minus 4. So if I put s equal to 4, this will be 0. So if s is equal to 4, my term will be 5 into 4 minus 3, which is 17, is equal to 4 plus 1 is 5 into a, so it's 5a, plus 0, the other term here, because 4 minus 4, and then a is equal to 17 over 5. Okay, so now I got my answer for a and b. So if you just can recall, we already had the answer. The answer was y of t is equal to a e to the power 4t plus b e to the power minus t. So that was my answer. So simply what I'm going to do here, I'm going to substitute to have my full answer, which is 17 over 5 into e to the power 4t plus b was 8 over 5 e to the power minus t. And that is the solution. And that is the solution for our first problem here. Okay, I hope that was easy. So let's go to the second example. So the second example that we are going to deal with here says that if I have a problem which is quadratic. So here I just want to mention that I had a problem that was linear. Okay, it was like, let me say that I had linear factors here. I had linear factors in that problem here. Okay, so as I can see, these are the linear factors that we have obtained here. So what I will try to do here, I'm going to go to the second example, and the second example that we are going to deal with, instead of the denominator to be the power of 1, we're going to have a denominator to the power of 2. Again, it was the first one was to the power of 2, sorry. Okay, so I think it's a similar example to what we are going to be taking here. So I will call this like a quadratic function. Okay, I think it's a very similar example. That's fine. We just want to practice more and more. So 6s minus 22 over 2x squared plus 7x minus 5. So if I have a problem like that, I just want to make sure if this can be factorized. Yes, it can be factorized, and the factorization is 2x minus 3 into x plus 5. And I'm not going through how to factorize things, because this is like straightforward from math. So please go back to your math to know how to do some kind of factorization. So continuing on that, so I have 6s. So I have 6s minus 22 over 2s minus 3 into x plus 5. Sorry, I will not say x, I will say s plus 5 into s plus 5. And what we are trying to do here, we are trying to separate that into two functions. So a over 2s minus 3 plus b over s plus 5 plus b over s plus 5. I'll just fix that, s. Okay, so this is what I'm trying to get here. And actually, just by getting here, I already can have an idea of my answer. Okay, and just to fix it to be s plus a, something that looks like s plus a. So if I just divide by 2, if I just divide this by 2, which means I'm multiplying half the denominator, and I'm multiplying by half for the numerator. So this will be like now s plus a, and a is minus 3 over 2. So here, if I will convert this, doing the Laplace inverse, my answer will be something like a over 2 into e to the power 3 over 2t plus b e to the power minus 5t. And since this is exponential of a positive term, if t goes infinity, this will be unstable. So this problem is also considered as an unstable process. So this is unstable process. Even though that I did not calculate a and b, I still can say that is an unstable process. Okay. And the second thing, other than I'm saying that it's unstable, I have the solution. I have the solution of my problem. It's there. Okay, so the only thing that I don't have is what? Is the value of A and the value of B. How to get the value of A and B? Very similar to the problem that I just have solved before. And I'm not going to go through the math because it's just solving A and B, multiplying both with the denominator and cancelling out the terms. So here I'll go to my third example, example number 3. So that is example number 3. So what does example number 3 say? So 7x minus 11 over x minus 2 the whole thing square. Okay, now this looks different. Why? Because I do have repeated root here, or whatever they call it, repeated factor, which is x minus 2 into x minus 2. And because I have it repeated, the way how to decompose it is a over x minus 2 plus, I will not say x minus 2 again, I need to say plus b into x minus 2 the whole thing square. Okay, so this is the way how to factorize if I have something that looks like that. Any function that is to the power 2, x minus 2 the whole thing square, or x plus 3 the whole thing square. So we just put the repetition of it. We just put the repetition as you can see here. And the thing is that don't get confused. This is x minus 2 the whole thing square. We said here should be one order less, right? It is one order less. We need to look at what is inside the bracket, which is to the power 1. And since one order less will be to the power 0, so nothing will be sitting up here. Okay, so it doesn't go with the square here. It goes which is what is inside the bracket. Okay, great. So if I again going to say that if I'm going to take the Laplace inverse of that, I'm going to get the answer after taking the Laplace as a e to the power 2t plus b. Oh my god, this is new for me, right? This is new for me. And actually, if you go and look at the timetables, the tables that we have, what does that look like? It looks like this is b e to the power, this is b e to the power 2t, definitely. But because I have square, it's going to be different, and I'm going to have the t term. I'm going to have something like a ramp. Okay, something like a ramp. And just to make sure that we know what we are doing exactly, so we are going to go back to the presentation. So this is what you're going to do. You're going to go back to the presentation. So that is lecture number 13, and that was part of lecture number 12 actually. I'm going back to the lecture number 12. And if you go to the Laplace tables, so these are the Laplace tables. Okay, so what does Laplace table say? Say if you have something like 1 over s plus b to the power n, and this is what we have. We have 1 over s, 1 over x or s minus 2 to the power n. So b was minus 2 for us. B was equal to minus 2. And to the power n, n was a square, so n is equal to 2. So all what you need to do is substitute here. So if you substitute, you will have t to the power 2 minus 1, so that will be t. E to the power minus bt, so e to the power minus bt, so it will be e to the power 2t. Okay, so that will be e to the power 2t. And to continue with that, you will see it will be under n minus 1 factorial. N is 2, so this will be 2 minus 1 factorial, which is 1 factorial, and 1 factorial is just 1. So the answer will be t e to the power 2t. T e to the power 2t. So what we are going to do here, we're just going to look at it. Okay, so that is exactly my answer. It is t. Okay, it is t e to the power 2t, exactly, multiplied by that b, which we did not calculate yet. How do we calculate this b? Again, we are going to calculate it through partial decomposition. That is through partial decomposition, and it is simple how we can solve that. Okay, so that's the answer. So that is the answer that we have. I think so. I feel that you want to go through the solution of that part to find a and b. So we are going to do the partial decomposition. We already did the partial decomposition, but we did not find a and b. We will try to find what? We'll try to find a and b here. Okay, you always need to find a and b, but we are going to do it here. And again, it's just math, so I'm going to do it here. So what we will try to do here, find a and b. So what is a and b? Okay, this is my problem here. So I will try to multiply by x minus 2 the whole thing square. So if I multiply by x minus 2 the whole thing square, I will get something like that. A into x minus 2, so because I'm multiplying x minus 2 with the whole thing square, plus b over x minus 2 the whole thing square multiplied by x minus 2 the whole thing square. It will cancel each other. So that is my equation if I multiply the denominator by x minus 2 the whole thing square. So now again, the simple solution that we can do, if x is equal to 2, so I'm going to cancel out this term. So if x is equal to 2, it looks like that I'm cancelling out a term here. Okay, so this will be 7x minus 11 is equal to that term, which is a into x minus 2. That will be like a into 2 minus 2, and a into 2 minus 2, of course. This is why we substituted 2, so that we can cancel out that term, plus b. And since x is equal to 2, I forgot to substitute here. So that will be 7 multiplied by 2 minus 11. So 14 minus 11 is 3. So b is equal to 3. Okay, so this is b is equal to 3. So we found b. What you need to do now here, the simple thing is to substitute b. And as you substitute b, you're going to have an equation which looks like that. 7x minus 11 is equal to ax minus 2 plus 3. All what you need to do is substitute anything for x, right? Anything for x to find a. And the simplest is to substitute like x is equal to 0. So that will be minus 11, 0 minus 2. So that is minus 2a plus 3. And if you take that minus 14 divided by minus 2, a is equal to 7. Okay, so now we found our answer. All what we need to do is to substitute, and my y of t is going to be equal to, if we just go a little above, I'm going to make this smaller just to look at the equation that I have up the top here. So that will be 7e to the power 2t plus, was it plus? Yes, b is equal to 3 plus 3t. Remember, it was e to the power 2t, t e to the power 2t. So that is t e to the power 2t. And that is my solution. That is my solution for the problem. So I just did the calculation of a and b for you to feel comfortable that we can do that very simply. Very simple. Okay, let's go to another example. So that was example number 3. So let's go to example number 4. In example number 4, and now we have realized that I'm using x. Okay, x and s is the same as a variable, so it's like I'm solving math. It will be in s because it is in the s domain, but we always have this x in our head, which is easier to solve because we are used to it. So if I have a problem of 3x squared minus 24x plus 53, and of course this is like y is equal to 3x squared. Okay, I always forget to write y is equal to, so it is something like that. If I have a problem of 3x squared minus 24x plus 53 over x cubed minus 6x squared plus 9x. Okay, so it looks like I can take an x as something here, as a common factor, and then I'm going to have x squared minus 6x plus 9, which is another x, which is another factorization that I can do. And if you do this, you're going to find out that it's going to be something like that. It's going to be x into x minus 3 the whole thing square. Okay, so this looks very similar to something that we had in mind we just solved. So the answer of that, if you want to decompose it, it will be a over x. Okay, so just write it. So this is 3x squared minus 24x plus 53 divided by x into x minus 3 the whole thing square. So this will be a over x sitting by its own plus b over x minus 3, and since this x minus 3 is like a repeated root, so this will be plus c over x minus 3 the whole thing square. Okay, And all what we need to do now, we multiply by this term here. So we multiply by x into x minus 3, the whole thing square, and we multiply this whole part by x into x minus 3, the whole thing square. And after you do this, you're going to get the term later to find a, b, and c. Okay, so and then you substitute x is equal to 0, and then you substitute x is equal to 3, and then if you find a and b, you're going to substitute any value for x to find the value of c. So this is how it gets to solve it. And as we said that, well, without going through the details, finding a, b, and c, we already can say that the answer will be a over s. If you remember a over s, the Laplace inverse for that was a. Okay, the Laplace inverse of that was a. And if you just look at it, I'll just remind you of that. So if you go back, so what is 1 over s? So 1 over s, if you go Laplace inverse, it is 1. It is 1. Why did it say s here? Okay, it is 1. Okay, it is 1 unit step. It's just 1. Okay, so 1 over s is 1, and a over s will be a. So going back, so this is a over s. The answer will be a plus 1 over s plus a. S plus a, and a is 0 is minus 3, so it will be e to the power 3t. I think you're getting used to it now. And this will be c t e to the power 3t. Okay, and that is my solution. So I got the solution here. I just need to find the values of a, b, and c. Great. So that was example 3.4. Now let us take an example 3.5. So this is example 3.5, and take an example of C3.5. Y, we say that y is equal to 6x squared plus 21x plus 11 divided by x squared plus 3 into x plus 5. Okay, so that is a problem that I have here, and in this problem, okay, so in this problem, what do I have? I have something which is this term here is not as easy that we would expect, and it will need some kind of calculations here, because I have x squared plus 3 and I cannot do any kind of variations for it. So this will be something like ax plus b over x squared plus 3. And why do we say ax plus b? Because this should be one orderless, and one orderless should be something of a form of ax plus b. Okay, and so this is what we are going to have for x plus 3, and this will be ax plus b over x plus 3 plus b over x plus 5. Okay, so that is what we have as a problem. Okay, this is what you need to solve. Well, now the question is, we know how to solve this. Okay, solving a and b is not that difficult. Oh, sorry, this is c. Okay, this is c, because we already have a and b here. Okay, so we know that the solution of that part, if we take the Laplace inverse of that, we are going to have the answer as c e to the power minus 5t. Okay, so we know that, right? What about this? If we take the Laplace inverse, what will be the answer? Actually, there's nothing that is straightforward that we can get out from here. Going to Laplace tables, sometimes you can get something that is hidden. The answers are not here, but actually from the Laplace table that you're going to supply to you, you're going to have something that is supportive to find out here, where if you have in the S domain something that looks like 1 over s squared plus a squared. However, I'm going to give you a hint that will support you a lot. If you have a solution of a denominator here that has complex numbers, definitely the answer here should be a sine or a cosine term, or a cosine, sine or cosine, or both sine and cosine. Okay, so it will have a sine term and a cosine term. It will have both of them. And actually, if this is just a key of what I had said, I will say it again. So if I have from the answer here, which means x squared plus 3 is equal to 0, which means x squared is equal to minus 3, x is equal to square root of minus 3, and that is minus 3j, right? So what I'm trying to say here, plus or minus, okay, I'll write that again. So that the answer of that will be plus or minus square root of 3j. Okay, because this is square root of minus 1 into that. Talking about the term that I have here, because I'm going to have a complex root, in my answer, it just gives me an indication that that it will have a sine and a cosine term. It just clicks into your head that this should be a sine and a cosine term. And looking at the Laplace tables, what do I have from Laplace tables? I do have the following. So this is the Laplace table. If you can see the Laplace table, so that is the Laplace table. Again, you can see that for if it is 1, it will be 1 over s. If it is t, it's 1 over s squared, and so on. So what about the sine and the cosine term that I was just mentioning? Okay, so you can see here from the sine and the cosine term, and what do I have here is that you can see that for sine b of t, the answer is b. The answer b, if you take the Laplace, the answer is b over s squared plus b squared. Okay, s squared plus b squared. So what do we have? We have x squared plus 3. And actually 3 could be represented as what? Square root of 3, the whole thing square. So we do have s squared plus b squared. Okay, so we do have that. And how did we know that there's something that looks like it? It's either I look at the Laplace tables, or I can know that. I can know that by looking at my denominator. If I look at the denominator and I find something that has a complex root, definitely I will know that this will be a sine and a cosine term. Okay, so this is the shape that what I have. This is a simple shape that we would have. However, if we have something like that, it will still look like if you calculate it, you will know that you have an exponential term, and you will have a sine term because you have a complex root, and you know that you will have an exponential term multiplied by the complex root, by the sine wave, by knowing that there's a complex root and by knowing that there's a plus a here. And we're going to solve an equation which looks like that. Okay, so what do we have? Returning back, so what I have is x squared plus 3 here, and my x squared plus 3 will look like something like x squared plus square root of 3, the whole thing square. And if I have something like that, I know that this denominator exactly looks like x squared plus b squared, s squared and plus b squared. So my b, in this case, my b is equal to square root of 3. And in this case, if I go back, if I say that my b squared, okay, so I'm looking at this term. Okay, I have two terms here. It's either this or either that. Okay, which one it will be? Is it the sine or the cosine? So if I go back, I have ax plus b. So I do have the s term and I do have another plus term. So it looks like the first part will be the cosine term and the second part will be the sine term. And if I write this equation now, which is ax, so I'm going to write x again. So if this is ax plus x squared plus 3, okay, plus b over x squared plus 3. And I'm going to write here the shape that I would like. So this is like that, plus that square. Okay, so it looks like now very similar to what we have. Looks similar to what? I have s over s squared plus b squared. So you can see s over s squared plus b squared, which is cosine bt. So I can see that this will be cosine bt. So this will be cosine bt. Okay, it will be cosine b, which is square root of 3t. And the other term will be, it should be x squared plus the term which is at the top there. If you look at it, it should be b over s squared plus b squared. So you need the b here, the b term, not the b squared, the b term. What is b? B is square root of 3. I don't have square root of 3 here, but what I can do in a very tricky manner, I can multiply by square root of 3 and divide by square root of 3. Okay, so what do I have now? Outside my term is b over square root over 3, and then I'm going to have like this term here, which if I take the Laplace inverse of this term here, this will be like b over s squared plus b squared, and this will be sine bt. And you can see here sine bt is equal to b over s squared plus b squared. Beautiful. So what I have done here, I have just showed you how to get the answer, for the terms that I have here, to get the answer directly, without of course computing a and b, because computing an a and b is just straightforward. You multiply the denominator, substituting values of x, and finding a and b. So that was not a big deal for me, but the bigger deal of how to find the answer y of t, how to find the answer of y of t equal that equation here, a cosine square root of 3t plus b over square root of 3 into sine square root of 3t. So I hope that you gain from that problem. It was a little more complicated, but you will get used to it. So I'm happy to look at it again. So I have a problem here. If I just look at the denominator, one part does not have complex roots, so it will be a normal exponential term. If it had a square, it would be exponential term with a t term. And in this case, for that, it has a complex root. And since it has a complex root, it will be a sine or a cosine or both of the terms as we had seen here. And to decompose it, here the numerator will be ax plus b, because it should be one order less than the denominator, plus c over x plus 5, and this is also one order less. Taking the Laplace inverse, this Laplace inverse for the second part is easy, it's e to the power minus 5t. However, the Laplace inverse for this one is not straightforward, we need to modify it. And modifying it is to make it as s squared plus b squared. So this is s squared plus b squared. This is not squared. To make it b squared, we make it square root of that number, the whole thing square. So square root of 3, the whole thing square. And then I separated the numerator, because I have ax plus b at the top there. So I separated ax plus b. And so I have ax. Now this is ready for me. S over s squared plus b squared. Okay. And in this part, it was not ready for me because I had b over s squared plus b squared. So I don't have b over s squared plus b squared as it is in the Laplace table. To have that b term, I multiply by the b term and I divide by the b terms like I'm multiplying by 1. So now this is ready for the Laplace inverse, and that Laplace inverse of this part is sine square root of 3t, and I'm left with what? b over square root of 3, which is here. So that is the solution of that part of example 5. Now let's go to example number 6. Example number 6, and in example number 6, we'll keep it now easier. We will not try to go to the details of everything because now you're getting used to the different terms that we have. Sorry, so this is 3x to the power 4 minus 2x cubed plus 6x squared minus 3x plus 3. You see that term at the top there? It's crazy, right? Over x squared plus 2, the whole thing square, into x plus 1. Okay, so what we can see here, and this is something that you should know, the denominator in our plants, chemical plants, will always be a higher order than the numerator. Okay, if you have the numerator greater, that will be something that is not chemical engineering or in chemical plants. Okay, so we will not deal with the numerator that has one order higher. Okay, because that needs to go through a long division and it has a different way of solving, but we don't need it, right? We're just talking about our systems here. Okay, so if you look at the denominator here is x to the power 5, like this is the x to the power 4 and multiplied by x to the power 5, so it is one order higher, so that is like it's applicable to what we're going to solve here. So how to decompose that? So we have at the bottom here x squared plus 2 plus another x squared is repeated plus 2, the whole thing square, plus x plus 1. So this is the thing that we have at the bottom. So if you go at the top here, so this should be ax plus b, because it's one order less. So this is square again. I will not look at the square outside, I'm looking at the one which is directed to the x. So this is also cx plus d, very similar. And here is just x, so this will be e. And again, this will have both sine and cosine terms, very similar to what we have done before. This will have sine and cosine terms. Again, why? Because both of these will provide to me complex roots, right? To give me a complex root. And this will also, very similar, it will have a complex root. And for this case, the answer will be if straightforward plus e to the power minus t. Okay, so this is the solution of example 6. Great. So let's take another example. I mean, you can take more and more examples if you would like, and I think so. I covered the main examples that I need to cover here, and all I have is just I'm trying to solve more problems to bring ideas just closer to your mind. So if I have a problem which is example 8, where y of s, now I'm just stating s, bringing your mind back to s, over s squared into s squared plus 4s plus 5. So if I'm going to decompose this, so this will be something over s, okay, plus something, again, I'm going to write this again, just smaller. So I have something over s plus another thing over s squared, so this is repeated. And this s squared plus 4s plus 5, can it be decomposed, so factorized? Can it be factorized? Let me check that. So let me see, b squared minus 4ac. So b squared is 16. Okay, if I'm looking at this, okay, I'm just looking at that here. So looking at that piece here, b squared minus 4ac under the square root, if you know that, that is part of the factorization thing. I just want to make sure if it has complex roots or not. Okay, so this is in my mind. If it doesn't, that means I can factorize it. Okay, I can factorize it into two terms, two brackets. So in this case, b squared 4 minus 4ac, so this will be like 16, 4 squared minus 4ac, 420. Oh, okay. So it looks like this is a complex, okay? It has a complex root, so I cannot factorize it. So the solution for that part definitely will be sine and cosine. And in continuing, so this, I will just keep it as it is. So it will be s squared. It will be s squared plus 4s plus 5. And in this case, I'm going to put here a over s, and this is s squared, so it will be one order less, so it's bs plus c. And this is also s squared, so this will be like ds plus e. Okay, so that is what we have here. And if you want to go for the solution part, if you want to look at the solutions here, the solution will be, for the first one, it will be just A. And for the second one, it will be, okay, so I have something confusing here, because bs over s squared, which is b over s, so the answer will be b, plus a c over s squared. The c over s squared is ct. Okay, beautiful. And here, definitely I will have some kind of sine and cosine terms, so it will need some kind of effort to work for this part. So that will be sine and cosine terms. I think in your head you're saying that, okay, can you solve that for us, please? It will help us to take another example. Okay, why not? Why not? So now I'm dealing with bx plus e over s squared plus 4s plus 5. So let's solve it. Let's solve it. Why not? So now I'm trying to solve this part here. So I will say that I have ds plus e, which you can find later, over s squared plus 4s plus 5. Okay. So how do you? We know that now this should have a sine and a cosine term. And how to solve that? We need to work on the bottom here. So it's not two terms. It's not like s squared plus b squared. If it's not s squared plus b squared, it is something like what we see now, s squared plus 4s plus 5. So definitely this is something like what? This is something that looks like the denominator here, okay? Or the denominator here. It's the same. S plus a squared plus b squared. So what I'm trying to say, we need to represent the denominator as s plus a the whole thing squared plus b the whole thing squared. We must represent it like that, so that we are able to do what? We are able to go to find out. We're able to find out these two terms here. Okay, to these two terms here. So that's what we're going to do. We're going to find s plus a the whole thing squared plus b squared, because it's definitely not s squared plus b squared, because we have a term in between them, which is it's not like s squared plus 5. Okay, there's a 5x, so there's s as well in between, and this is the s that we have in between here, right? Okay, so what you should do to work with this, we said that should be in the shape of s plus a the whole thing squared plus b squared. Okay, beautiful. How to do this? This is what I will try to do here. So in a moment, look at it. Look what I will try to do here. So this will be s plus a the whole thing squared. How to get the s plus a of the whole thing squared? We are going to take the first two terms here. The first two terms. So the first two terms will be s squared plus 4s, and then what I'm going to do, I'm going to divide by 2 this term here, which is 4 over 2 the whole thing squared. Okay, so why I'm doing this, I did not finish yet. Okay, I still did not finish the denominator, but why I did this, because I know that this part here will later be s plus 2, which is 4 over 2, which comes from here. It will be s plus 2 the whole thing squared. Are you sure that it is like that? Yes. Let's check. S squared plus 2ab, 2 multiplied by s by 2, which is 4s, plus b squared. Okay, plus 2 squared, which is 2 squared, 2 squared. Okay, so that is correct. Beautiful. So we got the s plus a the whole thing squared. But what did we do here actually? Okay, we added 2 squared. We added 2 squared. What we need to do here is we subtract 2 squared. So we need to subtract 2 squared, right? Because we added a 2 squared, we need to subtract 2 squared. So it's like we are adding a 0. Okay, so now we're on the safe side. We just need to now include the last part. We should not forget the plus 5. Okay, the plus 5. Okay, so this is what we have in the denominator here. So what do we have now? We have s plus a the whole thing squared. Beautiful. and the second term here. So let's continue and write that again. So that is ds plus e over s plus 2 the whole thing square, s plus 2 the whole thing square, plus 5 minus 2, plus 5 minus 2, and 5 minus 2 is 3, plus 3. And since I know that I want to appear this plus 3 as b square, what I'm going to do? I'm going to take the square root and make it square. So what is this value? Actually this value is 3. So it's exactly 3. It was the 5 minus 2 is equal to 3, right? So beautiful. So I have my term here, which is the square root of 3 to the power 2. So I have beautifully my term here. So I have now my s plus a square plus b square ready. Now we need to look at the numerator, if it has something similar, because I need to have, if I just go back, I need to have, if it is a cosine term, I need to have the numerator as s plus a, similar to the s plus a here. And for the sine term, I need to have b here, similar to the b here. Okay, so let's consider that I need to have s plus a. Okay, so I don't know what is s. Oh my god, I don't know what is d and what is e. Okay, because I don't know what is e and what are these terms, we are a bit stuck here. And it's difficult to find the answer that we need here. Okay, so it's difficult to find the answer here. Actually, it's easy to find the second part. The second part for the sine term, because we just multiply by square root of 3 and divide by square root of 3. So it's easier to the other part here, but the first part maybe is more difficult. Let me try something. I'm not sure if I will succeed with that. Okay, so I'll just try to separate it. So that is like ds over s plus 2 the whole thing square plus square root of 3 the whole thing square, and the second part, which is e over s plus 2 the whole thing square plus square root of 3 the whole thing square. And now in this part it is simple. Why? Because I will just multiply by square root of 3 to have my b term. Actually it is my b term here. My b term is square root of 3. Okay, let me say this is s plus a plus b square. Okay, yes, so b square, so definitely b is square root of 3, and we are going to divide by square root of 3. So that will be straightforward, and I already have my answer here. My answer, which will be e over square root of 3, multiply the whole thing term that I have here, which is sine. Before sine I have exponential term, because of this term here is different, so it will be e to the power minus 2t into sine bt. Okay, so this comes from here, and sine bt, which is sine square root of 3t. Okay, I like this. So I have now my answer. I know it is in terms of e, but I do have my answer here. Let me see at the other side. Here if I can do something. And actually it's not easy to do something here, because we have d. I want s plus 2 here. Okay, so what I can guess, what I just can guess here, if it's not easy, okay, what I'm going to do now is not straightforward. So I'm going to add, it's easier to have numbers, but if you don't have numbers, it's like I'm trying to create something. I'm saying that I'm going to add plus 2d. Okay, I'm going to add plus 2d just to be similar to the s plus 2 here if you take a common factor. And I'm going to subtract minus 2d. Okay, so what does that mean? I'm going to have my function here. If I just continue, I'm going to have it d into s plus 2 minus 2d. And I can separate now the denominator for both of these. So this is like that. So now I have my term here, which is d into s plus 2 over s plus 2, the whole thing square, plus square root of 3 square. I cannot believe that I already did this. Okay, so I have this term, which I already have the solution for it. So I have s plus a over s plus a, the whole thing square, plus b square. Whereas as the second part, now it became like a sine thing. The sine thing here. And what I need to do is I'm going to multiply by square root of 3. Again, the same story. And divide by square root of 3. So just looking at the answers here, the answer for these two terms, not to forget the first term here, the answer will be d. It will be d into e to the power minus 2t into cosine square root of 3t minus 2d divided by square root of 3 into e to the power minus 2t into sine square root of 3t, and not to forget the term that we had here that comes on, which says plus e over square root of 3 into e to the power minus 2t into sine square root of 3t. Beautiful. So we solved this problem. And how beautiful we can find our answers without even going through what? Without even going through finding the values of a, b, c, and d, and e. And how beautiful is that? And actually this is also this is the part that we solved for s squared plus 4s plus 5. There was the other part, which is a over s plus over b over s squared. So we need not to forget those two terms. So those two terms, where are they? Okay, so I meant those two terms here, right? So these terms here, we should not forget this. So it's a plus b plus ct. Okay, so I will include this as the final part. So a plus b plus ct. Okay, so that is my whole solution here. That is my whole solution here of my problem. Okay, great. So this was part of the answer that I got here. And what else do I have? I'm going to solve just one final problem. It's a very simple problem, just to leave you with a simple problem. So if I have a problem which says 1 over x cubed minus x squared, for example. So if I just factorize this will be 1 over x squared into x minus 1. And if you just put, this is it's something over x plus something over x squared plus something over x minus 1. Okay, so this would be like a over plus b plus c. If you multiply by this denominator here for both sides, so you will get an answer. So you will get the next step as let me write the left hand side. The left hand side will be 1. Okay, just that one here, because I'm cancelling out this term by multiplying by the same term, is equal to a into x minus 1 plus b, the x squared goes with the x squared, so it will be into x minus 1, and the last term, if you multiply, x minus 1 cancels out, so it will be plus c into x squared. Okay, what I will try to do here, I'll try to solve it in a different way, because I can say that, well, if x is equal to 1, okay, if x is equal to 1, this will be, the 1 will cancel out here, it will cancel out here, I will have c, so c into 1 square, so c is equal to 1. Is that easy? Wallah, it is that easy. So, and if x is equal to 0, and actually if x is equal to 0, you can see that this will be 0, and that will be 0, and this will be 0 minus 1, which is minus b is equal to 1, so b is equal to minus 1. So b is equal to minus 1. It's that easy. Yes, it is that easy. And how to find a? Okay, to find a, just substitute anything, okay? So if you just substitute anything, like x is equal to 2, okay? So if you substitute x is equal to 2, this will be 1 is equal to 2a, we already know what's the value of a. No, we don't know the value of a. Into x minus 1, 2 minus 1 is 1. Okay, so that's just 2a. Plus b into 2 minus 1. So that is b. And what is b? It's minus 1. So I'll write here minus 1. Plus c into x squared. X squared is 2. So 2 squared plus 4c. It will be 4c. And c is 1. So it's plus 4. So you already can see here that we can calculate it. So that is 1 plus 1 minus 4. So it's 2 minus 4 is minus 2. So this a is equal to minus 1. So we found all our terms here, and then you need to write your final term, of course, in the sxx domain. So or now we're dealing with x, not s. So my y, which is function of x, will be equal to I need to recall a plus b plus c. So that is minus 1 over x plus, so again b is minus, so it's minus 1 over x squared, and the third one I think it was plus c. Yes, it is plus, definitely. So plus c, which is 1, which is 1 over x minus 1. Okay, so that is plus 1 over x minus 1. And the solution of that, if you take the Laplace inverse, if I ask you to find what is y of t, okay, so if I asked you to find what is y of t, so you need to do the Laplace inverse so that you can find y of t in the time domain. And finding y of t, this will be 1 over s, so it's just the minus 1, the term. Here is minus over s square, which means t, so it's minus t, and that is 1 over s plus a, and s plus a is the exponential term. The a is here, it is e to the power minus at, a is minus 1, so this will be e to the power plus 1t. Okay, so it's e to the power t, and definitely you can see if t is equal to infinity, this will be unstable. So I can say that this is an unstable process. And you can know that this system is unstable just by looking at what? Just looking at the denominator here. We did not talk about instability for the sine and cosine. I just forgot that. It goes similarly. But definitely for sine and cosine, it shows the instability if we have the sine and the cosine term which goes up and down. Okay, so it could have that as well. So we'll talk more about stability later, but this is the way how we can solve our problems in the Laplace domain. So looking forward to see you in lecture 14. So all the best. So I will say that see you in, I would like to use that color, lecture 14. And lecture 14, we're going to talk about what? We are going to talk about linearization. Okay, let me write that again. So that is linearization, and how to put things in a deviation format, plus putting it in a deviation format. Okay, I like these colors, so a very happy face, and I think we have done a good job here, and all the best. We have done a very good job here in looking at our problems. So see you in lecture 14. Bye. مع السلامة.